So welcome to 4Ks Private Tuition. So in this particular video, we're going to be talking about the factors that affect the speed of a chemical reaction. So the first factor that we're going to look at is temperature. So when you have a higher temperature, when temperature increases, we are going to have our particles gain more energy. The particles will gain more energy, and when this happens, they are going to move faster. So when our particles attain more energy, they move faster, and when this happens, we are going to have more frequent collisions. So if you remember from our previous video, we said the particles must collide, which is called the collision theory, in order for them to react. And when they collide, they are what we call successful collisions, which will result in the formation of a product. And there are others that are unsuccessful collisions. For example, when particles collide without enough energy, which is called the activation energy. So particles require a minimum amount of energy that will allow them to react into products. And if particles do not have this energy, then they are going to collide and have unsuccessful collisions. So you should remember that temperature here, what it simply does is that it's going to make your particles move faster and hence increase the frequency of collision. When you increase temperature, you also increase the energy of the particles. So the particles collide with more energy, and they are more likely to exceed activation energy, the energy that is required, the minimum amount of energy that is required for particles to react. So we are saying here, you increase the frequency of collisions and you also increase the energy content of the particles at the same time. And so what will happen is that you're going to have a higher rate of successful collisions and hence a higher rate of reaction. So let's move on here. We want to look at another factor, which is concentration or pressure. So concentration or pressure are the same under that because they refer to how many particles are there per unit area or per unit volume. So they represent the same factor here. So we are saying per unit volume, how many particles are there, how many moles are there. That would be your concentration, and which is the same thing with your pressure. However, pressure works for gases and concentration for solution. So what would happen if you increased your pressure or concentration? When you do so, we are saying here you're going to have more particles per unit volume, and you are also in turn going to increase the frequency of collisions, and this increases the rate of your reaction. So this is important for you to remember the sequence of events there. And then for surface area, what would happen if you increased the surface area? When you increase the surface area, this will increase the rate of your reaction. Let's use an example here. If you wanted to react 3 grams of magnesium here with your acid, the rate is going to be different if you used a block, if you used granules, or if you used powder. So we see that there's an increase in surface area from our block there. The granules have more surface area, and the powder has the largest surface area. So our rate is going to increase with increase in surface area. So the highest surface area there to volume ratio is with the powder. Okay, so these are the factors that you must remember for when it comes to explaining the speed of a chemical reaction. So we see that with a high surface area, you also increase the frequency of collisions because you have more particles there and they can collide more frequently. So I think that's it for this video. I'll meet you in another video. In fact, there's one more factor that we have to look at, which is catalyst. So catalyst, these are okay. Let's look at catalyst before we go. So these are the substances which speed up the rate of a chemical reaction, but they do not participate in the chemical reaction themselves, so they are not included in the balanced chemical equation. So let's see how our catalyst operate here. So we can do so by looking at the energy profile diagram of a reaction. This would be an exothermic reaction. So if you still remember, we say there's an energy called the activation energy, which I've shown in dotted line there. So that's your activation energy. So what a catalyst does is that it lowers the activation energy, which is the minimum amount of energy that is required to kickstart a reaction. So your catalyst will lower the activation energy by providing an alternative path or route for the reaction. So catalysts act by lowering the activation energy. So okay, so when you have a lower activation energy, you're going to have a higher proportion of successful collisions because most of the particles are going to be able now to attain this level of energy that is required to kickstart a reaction. So when you lower it, that means most particles are going to be able to have this amount of energy, and hence we are going to have a higher proportion of successful collisions. So basically this is how catalysts work. So that's it for this video. I will meet you in another video. Thank you.